So hello everybody, this is Shivam Rajput back again with a new video on a video series of CSI and Jet for scientists. So finally on a special request of Tejashwini Burma and Kumar Gaurav, I am going to discuss about tropical easterly jet stream. Now this particular topic is very important. This is least known jet stream. It is very important for Indian monsoon, and we like every year in CSIR we have some questions on Indian monsoon. So be there with me till the end of this video and we'll discuss everything regarding the same. This video will be detailed analysis about tropical easterly jet stream TEJ. Okay. By the way, from morning we are having a massive discount on our website called www.earthoholicacademy.com. Now the combo price is having this much of money, 4,000 only. We have discount of 4,500. This particular offer is valid for first 100 students only, and most of them is already I think registered. So quick, do as soon as possible. Join www.earthoholicacademy.com right now. So let's discuss tropical easterly jet stream first. So before explaining TEJ, I will give you the link of jet streams, which is over on your screen. Have a look. Once you get that video, then only start TEJ. Okay. Before starting definition of TEJ, I would like to discuss about jet stream first. So here we can see that there are two jet streams over here. This is permanent jet stream in northern hemisphere called polar jet and subtropical jet. Here we have again subtropical jet and polar jet. So there are two permanent jets in the northern hemisphere and two permanent jet stream in the southern hemisphere. Both are having same name. Both are moving from west to east. Okay. Now this is your temporary jet streams. Tropical easterly jet stream is basically a temporary jet stream which moves east to west, and it forms in a certain condition in summer season. So I will discuss that. But what is jet stream first? Jet stream is basically a geostrophic wind. Now what is geostrophic wind? Geostrophic wind is basically a wind where pressure gradient force is equal to Coriolis force. Okay, so jet stream is a geostrophic wind blowing horizontally through the upper layer of troposphere. It always moves in a upper layer of troposphere from west to east. If I am talking about permanent, then it is west to east. Okay, now this jet stream develops where the air masses of different temperature meets. So here we can see that we have two different cells. No, this is polar cell, this is Ferrel cell. In between them there is a jet stream. Here we have Hadley cell and Ferrel cell. In between them we have subtropical jet stream. So it always forms where the air masses of different temperature meets. So we can say that the surface temperature determines whether the jet stream will form or not. Here the surface temperature on the poles is very cold as compared to the mid latitude region, and that's the reason why there is a formation of different temperature belts, different you can say air masses, and in between these different air masses there is a frontal zone, and along that frontal zone there is a movement of jet streams. Now let's talk about this TEJ. Okay, now this TEJ, it's a full form. TEJ means tropical easterly jet stream. It is a low level jet. Okay, so this TEJ is low level jet. Its height is much less than this polar jet or subtropical jet. Okay, it is close to tropopause, while its height is not close to tropopause. It is say some height of 5 to 8 kilometers. Okay, and since it is close to the equatorial region, so we already know the height of tropopause in the equatorial region is somewhere 16 to 18 kilometers. So you can say it is almost half of that tropopause height. Okay, now in topics, the most prominent jet streams are tropical easterly jet stream, which is also known as African easterly jet stream. So it also blows over the Africa, and there is another jet stream called Somali jet stream. If you compare tropical easterly jet stream with Somali jet stream, the height of tropical easterly jet stream is more. It is at higher heights relatively compared to Somali, while the Somali jet flows exactly on the surface. Okay, close to the surface. And this tropical easterly jet stream is also known as African easterly jet stream. Okay, now this TEJ is basically in the northern hemisphere. This is the another property. It is always in the northern hemisphere. Okay, it is more prominent, you can say. So it found near 5 to 20 degree north. Okay, This is the main reason where it is strongest, 5 to 20 degree north. And this point to be noted, it's very important. Already there was a question in CSIR. Okay, now this TZ forms when there is a shifting of subtropical jet stream. So for that, we need to know this photo. Okay, we have to go through this photo. This is your westerly. Okay, now in winters, what we have is the doldrum region is somewhere close to southern hemisphere. Okay, it is in southern hemisphere in January. We know there is a movement of ITCZ, right? And with ITCZ, the entire doldrum region move up and down. And why it is moving up and down? Because Earth is tilted. So in January, the southern hemisphere is towards the sun, and that's the reason why the thermal equator is in the southern hemisphere. Okay, but as you move towards the summer, see, this is again January. In January, there is a high pressure on the land and low pressure in the ocean region. So that means ocean is much warmer than the land because of specific heat. Okay, so that's the reason why in the winters the wind flows from land to ocean. Okay, so there is a kind of land breeze. So land से ocean की तरफ जा रहा है. So it's like a land breeze. But in summers, we know that southern hemisphere is now away from the sun and northern hemisphere is towards the sun. So now this ITCZ is start moving in the northern hemisphere. So you can literally see this ITCZ is having some whitey patch. Why there is a whitey patch? Because these are the low pressure regions, and just above this we have cloud formation. Convection is going on, and because of this intense convection over there, we have clouds. Okay, that's why it is patchy in nature, and the line over here is curved. It's all because of there is a differential uh, presence of water and land. If there is a same kind of land everywhere of same composition, the line will be straight. Since we have differential presence of land and water masses, somewhere we have continent, somewhere we have ocean. That's why the thermal equator, the ITCZ, is curved. Okay, this is the July situation. Now ITCZ is moving above the plateau of this thing, Tibetan plateau. That's why here we have intense warming, and intense warming creates a low pressure over here, while the high pressure is there in the ocean. So now because of this, since low pressure is there, high pressure is in the ocean, pressure gradient force will develop from high to low, and it starts moving the air towards the Indian subcontinent. Okay, now this particular TJ basically affects Indian monsoon. It never affects East Asian monsoon directly. There are some indirect relations on research papers. Still, it is a part of research. It is a topic of research, but it has direct impact on Indian monsoon as well as African monsoon. So some parts of Africa is also having monsoonal rainfall. So it has direct effect on these two regions. Okay. Now let's talk about how this tropical easterly jet stream forms. So during the month of you can say January, November, all these things. At that point of time, what happened is we have STJ over here over Indian subcontinent. Okay, in the month of November, December, we have STJ over Indian subcontinent. As we move from November, December, January, February, like that, as we move towards the summer season, this STJ is now moving behind the Himalayas. So here we have Himalayan region. Right now, this point is called Pamir Knot. Okay. So right now, this STJ subtropical jet stream is divided into two arms because of the Himalaya from the Pamir Knot, and again rejoining over the eastern Chinese region. Okay, East Asia region. So here it is again joining and again moving towards eastern part. Okay, but as you go towards the month of May, somewhere close to the May, this STJ slowly start moving towards the the northern face of Himalayas. Okay, so now there is no more STJ over the India. Now this is the perfect time for the formation of TJ. Okay, So write it down. It's very important. TJ always comes into existence quickly after the STJ has shifted north of Himalayas, and that is from somewhere at the end of May and the first week of June, and then only you can say the monsoon starts. There is a outburst of monsoon. Okay, is this clear or not? Now, this TJ flows from east to west over peninsular India at a height of 6 to 9 kilometer and also over the North African region. So, not only the India but also the North African region. Here, you can ask one simple question: how this STJ movement is related to formation of TZ? So, TZ is moving like this. These lines are TZ lines. Okay, so why it is happening so? In the previous video also I told you there is a video on this thing, uh, upper air circulation. I will give you the link over here. Just have a look on that. The upper air circulation is responsible for formation of low pressure zone and high pressure zone on the earth's surface. Since there is a northward movement of this STJ, now we have ITCZ over this region also. Here we have now formation of ITCZ over the Pami Knot or Tibetan Plateau, right? So now there is a formation of low pressure. Low pressure because of what? Sorry guys, let me off the internet. Okay, now it's off. Okay, so now what I'm saying is because of the northward movement of STJ and because of formation of ITCZ over Tibetan Plateau, there is a formation of low pressure. Now, whenever we have low pressure on the surface, that simply means there is a convergence of wind, there is a cyclonic condition, uh, and whenever there is a convergence of wind on the Earth's surface, it will literally rise up. And once it will rise up, it will it will diverge in the upper atmosphere. You can see lower atmosphere mein there is a convergence in cyclonic flow, and upper atmosphere mein we have divergence. So this diverged air now starts moving towards this region, towards the equatorial region. Okay, and it is not simply move in a straight line. Instead of, it will have some curved path. Some part of it also moves over the Africa. Okay, so in this way it will form TZ, that is tropical easterly jet stream. Now the formation of TZ results in reversal of upper air circulation. See, in a case upper air circulation till now it is moving from west to east, but once TZ will form, there is a reversal in the upper air circulation. Now the wind will move from east to west. And why it is doing so? Because of high pressure is now switching to low pressure region. Initially in winters there is a high pressure over the Tibetan Plateau. Okay, but now here we have low pressures, and that's the reason why there is a switch in this. Okay, are you getting my point? Now you can see that here this is the May situation. So May situation may we have Pami Knot over here. The STJ is having two arms which again rejoins in the eastern Asia. Okay, during the month of May we don't have any rainfall. Okay, it's a pre-monsoon time, right? You can see it's a pre-monsoon time. At that point of time we have rainfall in the Andaman and Nicobar region, you can say. But mainly the first day of June, and then June onwards we have intense rainfall over the peninsular India, and then by 15th of June rainfall reaches somewhere in the Indo-Gangetic plain. Okay, so in May you can see the situation. Why there is no TJ? Because there is a presence of STJ over India, over Tibetan Plateau. Okay, is this clear? Now, in the month of June, you can see that now this STJ is shifted away from Himalayas towards the north of Himalayas. So once it is in the north of Himalayas, now we have intense low pressure to form convergence on the Tibetan region. So this converged air now starts moving up, and in the upper atmosphere it got diverged, but the divergence is in a simple direction. देख रहे हो ना, Over here there is a divergence, but the entire divergence is there in this region. Okay, for this, check out my upper air circulation video. You will come to know why there is a single direction divergence. Okay, now here you can see that it get diverted towards this region. This is your TEJ and it is moving in the upper atmosphere. Again, the height will in between 6 to 9 kilometer. Okay, now this particular region you can see over here, it is turned again into this direction. Now what is the reason behind it? The reason is equator. Okay, so just below this there is equator. Since the photo is 2D and I want to explain in 3D, that's why there is a difficult to understand this particular topic. यहाँ देख रहे हो ना, एक्चुअली में ये जस्ट above इक्वेटर के, ओके, एंड वी नो दैट once you cross the equator, the Coriolis deflection direction will change, right? So Coriolis deflection direction is now this way. Okay, it get deflected. We know, no, in the southern hemisphere everything will move towards the left. So for this, left direction is this one. For this wind direction, left is this one. So it get deflected over here. Now here we have high pressure zone. On the Indian Ocean there is a point called Mascarenes High. It is a high pressure zone. It's a permanent high pressure zone which moves, you can say, east and west throughout a year, but there is a high pressure zone at that very latitude. That is called Mascarenes High. Higher the high pressure region over Mascarenes High, better the rainfall in India. Okay, now why it is sinking over here? What is the reason? It's all because of Bibalot's law. If there is a low pressure on the earth's surface, that means there must be a high pressure on the upper atmosphere. And if there is a high pressure because of Mascarenes High in the somewhere close to the Madagascar, then there must be a low pressure over this region. Okay, so see, if low pressure is over here, that means there is a high over here. So high is always attracted towards the low, no? इसके ऊपर low होगा, इसके ऊपर high है तो high is related with low, low is related with high. So high to low there is a movement, and on the earth surface also there is a movement from high to low. So Mascarenes High is having high pressure while the Tibetan plateau is having low pressure. So again wind will move this way. And why it is deflecting in the other direction? Why not wind is going like this, like this? Why? The reason is again because of this thing, because of, you can say, Coriolis force. It's all because of Coriolis force. Since it is now crossing equator, no. So after this point, it is turning this way. Okay. So this sail, there is a formation of convection cell, right? So the upper part of this sail is called tropical easterly jet. Point to be noted here is the upper part of this sail is called tropical easterly jet, while the lower level movement on the surface, just on the surface, that is called Somali Jet. And stronger the TE jet, stronger the Somali Jet, better the rainfall. Okay, is this clear? So Somali Jet is a low level jet. Okay, it's very close to the surface, while this tropical easterly jet is again low level jet, but the height varies between 6 to 9 kilometers. Is this clear? Is this clear or not? Now stronger these sail, more the rainfall. Okay, in the monsoon video I will relate the tropical easterly jet streams with this thing, Walker circulation with INSO and all. I hope you got it. Okay, now when the summer temperature over the Tibet region, so this is your Tibetan region, right? If it is very high, if the temperatures are very high, and if the temperatures are sufficient for a long period of time, then there is a more chances of stronger TEZ. So low, intense low is very important for the formation of TEZ, and it will result in heavy rainfall in India. Okay, one more thing, if there are some research paper which shows that if there is a more snowfall, if there is a more snow cover over the Tibet region, over a Tibetan plateau, in that case TZ will become weak and there will be less rainfall in that very region, in that very area. Okay, even the entire India you can say. Okay, so the coverage of snow will inversely proportional to the formation of TZ. If less coverage, more heating, that means stronger the TEZ. Again, this particular concept is already asked in CSIR, and maybe in future they can ask some questions based on this. Okay, this is your Somali jet. You can see it is again moving from this region. Somalia is over here. Okay, part of African continent. So that's why we have Somali jet stream, and here there is a Somali current also. On the river we have Somali current, and in the atmosphere we have this Somali jet. Is this clear or not? If you have any doubt, feel free to ask in comment section. Now this Somali jet, if you talk about this Somali jet, again this Somali jet is not a permanent jet, it is a temporary jet. It forms only when TZ starts. जब तक TZ नहीं बनेगा तब तक Somali jet नहीं बनेगा. So both are related, like this Somali jet is dependent upon the TZ. Again, this is a narrow wind channel having speed of some 94 to 100 miles per hour. Okay, it moves in the lower atmosphere, middle atmosphere. It can this thing fluctuates. Okay, but it is closest to the surface. Point to be noted, amongst all the jet stream, the Somali jet stream is closest to the surface. Okay. Is this clear? Right. Now, if these jet stream will be become more strong, in that case we have sometimes flood like situations. अगर बहुत ही ज़्यादा strong हो जाए, this T jet and this Somali jet, in that year we have flood like conditions. Okay. So if there is a stronger high pressure region close to the Madagascar, somewhere here, okay, this is a Mascarenes region. तो यहाँ जितना भी high pressure होगा, the stronger the Somali jet will form. Okay, so high pressure and low pressure का difference जितना ही ज़्यादा होगा, stronger the Somali jet will form. Okay, is this clear or not? Again, it is there in the summer monsoon. This T jet as well as Somali jet is there in the summer monsoon. In winters there is no more presence. That's the reason why it is a temporary jet stream. So that's it for TJ and STJ. Hope you like the video. If you have any doubt, then feel free to ask in the comment section. I will make a video on that also. Chalo, bye.